So now what we are looking at is when an alternating current is passed through different components. So components what we are considering is a resistor, an inductor or a capacitor, okay, or combination of these three. So if you have a resistor, let's see what happens to the EMF and current. Okay, now consider you have a pure resistor connected to some alternating source. All right, so let's say E is equal to E naught sine omega t is the EMF which is coming from the source. Okay, so now what we have, as the EMF is changing, okay, that means the instantaneous EMF. So E is equal to E naught sine omega t. Once that passes through a resistor, so a current will be drawn by the circuit, correct? So we have, which is E by R will be equal to E naught by R sine omega t. Now E by R will be the instantaneous current, which is I, and E naught by R will be the peak value of the current, which is I naught. So we get I is equal to I naught sine omega t. So what we have is E is equal to E naught sine omega t and I is equal to I naught sine omega t. So what we say is EMF and current are in phase when an alternating current is passed through a pure resistor. Okay, now this is the circuit diagram which you guys have been seeing. Now we have two more diagrams which you guys have to know. One is using a graphical diagram, which is the sinusoidal wave, and another is a phasor diagram. See, this is the sinusoidal diagram. So this is the EMF, which is E naught is the peak value, and this is the current, I naught is the peak value. Okay. Next is a phase diagram or a phasors. So in phasors, see, phasors gives you the relation between the E and I, how much of the phase difference is there, correct? Here both of them are in phase. So if this is E, then this will be I. Okay, so both EMF and current are in phase when AC passes through a pure resistor. Okay.